Okay, in this video I'm going to continue on with my tutorial videos on thermodynamics and statistical mechanics. This is video number 2 and we're going to discuss the first law of thermodynamics. The previous video to this will be the meaning of temperature and heat, where I gave a brief introduction into what temperature is and what heat is. So the first law of thermodynamics is the most simple. Well, there is a 0th law, but I'm not going to discuss that here. So in thermodynamics, generally there are 3 quantities which we must discuss. There is temperature, energy, E-N-E-R-G-Y, and heat. Usually we talk about those 3 quantities. However, I'm also going to add another quantity which is going to be called work. Now, for a reason you'll see in a moment, I'm actually going to write them like this. So immediately you should be thinking clearly there is a connection between energy and heat and energy and work. Well, if you saw my previous video, you would know of course that heat is energy. If heat is the spontaneous flow of energy. So we'll talk about that in a moment. So first of all, what is temperature? Temperature is a measure of a body's will, or we'll say tendency, to spontaneously give up energy. So the body which spontaneously gives up energy is said to be at a higher temperature than that of the body which is receiving the energy. So that is what temperature is. Well, next, what is energy? And that's a very good question, and I'm not really going to address that. It's kind of one of these things you have intuition as to what energy really is. An actual description of it might be quite difficult. So I'm going to assume, probably maybe unfairly in fact, that you can write down and say what energy is, but let's move on from that. So we have temperature, which I said is the measure of a body's tendency to spontaneously give up energy. And then there's energy. And I'm saying that there are 2 forms of energy that we talk about generally in thermodynamics. And the first one is heat, and the second one of those is work. So let's think about a body, right? So let's say we have a thermodynamic system. Here's my thermodynamic system. And from now on, I'm going to use the symbol capital U to talk about the internal energy of a system. So there's my system. Now if I were able to measure that the internal energy of my system went up, that means that some energy must have flowed or gone into my system somehow. It must have got into my system somehow. Alright? However, if I measure that the internal energy of my system is after going down, that means that energy is after flowing out of my system. Alright? So if the internal energy goes up, well then some form of energy has gone in. If the internal energy goes down, some form of energy has gone out of my system. So now let's talk about what heat and work are. Well, in the first video in this particular series I spoke about what heat is. And I said heat is defined as any spontaneous flow of energy from one object to another caused by a difference in temperature between the objects. So let's see if we can paraphrase that. Spontaneous flow of energy due to temperature difference. So that's what heat is. So next we need to ask ourselves, what is work? Well, work in thermodynamics is defined as any other transfer of energy in or out of our system. So we have work. It's any other flow of energy in or out of the system. Alright? So you can do work on a system whenever you push a piston or whatever, if you stir a cup, or if you lift something you're doing work on it, or you move something you're doing work on it. So there are lots of different ways in which you can do work. In each case the system's energy will increase, and often, in fact usually, the temperature will also increase, but we can talk about that later. But we don't say that if work is being done on the system, we don't say that the system is being heated. Okay? If there's work being done on the system, We do not say that it has been heated. Okay, so that is something you should never say if there's work being done on the system. And this is because the flow of energy is not a spontaneous one caused by a difference in temperature. Because if it's a spontaneous one caused by a difference in temperature, well then it is a flow of heat, and therefore we're saying that work and heat are different. We're going to treat them differently, we're going to account for them differently also. So usually with work we can identify some form of an agent which does the work. Okay, so for example, if you're looking at a car, the car's engine has a piston. Okay, so you can say that the agent performing work on the gas is the piston. Or if you're lifting weights, there's work being done on the weights, the agent performing the work is you. Alright? So we can say that the work, we've identified the agent that is actively putting energy into the system. And without the agent, it would not automatically happen. Okay? So the agent, it is not automatic. It is not spontaneous. So that's the fundamental difference. Heat is spontaneous due to a temperature difference, whereas work is not spontaneous and it is due to an agent performing it. So the definitions of heat and work are not easy to internalize because, well, both of these have different meanings. Both work and heat have different meanings in everyday life. Alright, but like for example, you know, if you rub your hands together, you might say that you're heating up your hands. Well, in actual fact that's incorrect, because there has been no spontaneous flow of energy due to a temperature difference. What you've done in fact is performed work on your hands. Alright, so I'm going to move on from that and let's actually discuss the first law of thermodynamics. So that both heat and work refer to energy in transit. Okay, so heat, work, moving energy. Okay, it's moving energy. Well, because if you think about it, well, think about the definitions. The definition of heat is a spontaneous flow of energy due to a temperature difference. So there's no, there is no meaning, or it's meaningless to ask how much heat is in a body. That is a pretty meaningless thing to ask. You say how much heat is moving. Absolutely, that is a meaningful question. But similarly, if you talk about work, well, how much work is in a system? Well, work is we'll say defined as energy being done, or we'll say it is energy going into an object by the movement of an agent or caused by an agent. So to say how much work is in a body is also a meaningless question. What we can talk about, however, is the work being done on it, or the heat being we'll say the heat flowing into or out of a system. Now both of these are forms of energy, of course. Now next, if we said that U is the internal energy of a system. Now how do you make the internal energy of a system go up? Well, you either perform positive work or you give it positive heat. How do you make the internal energy of a system go down? Well, you do negative work. You make the system actually do some work on something else, or you bring it in contact with a cooler body, and if it's in contact with a cooler body, the temperature difference will be away from your system and it will spontaneously give up heat to the other system. So the point I'm trying to make here is that work and heat are referring to energy in transit. So we can't talk about the internal energy and work and heat. What we can talk about is the change in internal energy and work and heat. So I'm going to define the change of internal energy is equal to the heat put into the system plus the work done on the system. Now, you might see this law written as delta U is equal to Q minus W also. Now, neither are wrong. Neither are wrong. The difference is how one defines what is positive work and what is negative work. So in all my videos, I'm going to define work as being positive when work is done on the system. So W is positive work done on system. That's when work is positive. And Q is positive when heat enters the system. Now this is important because the sign convention, as we'll see later on, is very important. So any of my videos, I will refer to work as being positive when work is being done on our thermodynamic system, and negative when the thermodynamic system is doing work on something else. Alright, so this is called something, this law, this is an actual law, and we call it the first law of thermodynamics. So the first law of thermodynamics relates to the change in internal energy of a system due to either the flow of heat or work being done on the system. It's pretty straightforward, in fact. So I'm just going to give an example here. Let's say we have a thermodynamic system. Here's our thermodynamic system, and we bring along a Bunsen burner. Here's my Bunsen burner. So the Bunsen burner is going to be hot, okay, and let's say my system is cold, or that there is a temperature difference. Okay, let's say, I'm going to put in some numbers. Let's say this is at 100 Kelvin, and this is at 3 Kelvin. Very cold system. So that means that there is a change in, or there is a difference in temperature, and this is going to cause a spontaneous flow of heat from my Bunsen burner in here. So what we're going to get is, we're going to get a positive heat flowing into my thermodynamic system. Alright, now let's say my thermodynamic system is actually slightly larger, and what we have here is a piston. I'm going to dash the line and call it a piston. Now, let's say that I come along and I push my piston down. Let's talk about the work being done. The work is being done on my thermodynamic system by the piston, so in this case W is positive, and the change in internal energy is going to be Q plus W. Alright, no problem there. Now let's say, for example, that I'm after heating up my thermodynamic system with my Bunsen burner, and it gets very, very, very hot. In actual fact, my thermodynamic system is hot, but my environment is cold. My environment is cold. So we'll talk about it later on as to you know, what actually happens here. But let's say if my environment, sorry, my thermodynamic system, my enclosed thermodynamic system is hot, this one is closed or cold, this means there's going to be a pressure difference. This is going to be a large pressure, and outside in the environment it's going to be a small pressure. And this is going to cause my piston to actually move this way. So this time, what's causing my piston, which way is my piston moving? Well, it's moving away from my thermodynamic system. What is the agent causing this work to be done? Well, the agent is the actual thermodynamic system itself, and the work is being done by the thermodynamic system. So that means this time the work is minus W. So to get the change in internal energy, delta U is equal to Q plus minus W, or Q minus W, because work is being done in this case by the thermodynamic system itself. So that's all I've got to say about that. Thanks for watching. Please pass it on to your friends, subscribe to my channel, and if you're in a good mood you might also click on it out. Thank you.